In this video, we're going to review all the different parent functions that we've talked about. So we've talked about 8 different parent functions, and then we're going to talk about how they can move up and down and left and right. So we're going to start with the linear function. So the general equation for a linear function is y equals x. Now, a lot of the time, we see y equals mx plus b. Which is a variation of y equals x, where m is your slope and b is the y-intercept. So that's kind of what we're talking about over here. So the general graph for a linear function is going to be a line going uphill that looks like that. Now, if you look at this, it talks about the shifts and how it can move up and down. So the b value will tell you whether you're moving up or down. So for example, if we had y equals x plus 2, then we would be moving up 2 from the general graph. So you'd have a line that went up 2 from the origin. If we had something that looked like y equals x minus 3, then we're going to go down 3 from the original line. So the original line was the red one, so we're going to go down 3. So that would be what that line would look like. If the a value is negative, then it's going to be reflected, so it's going to go downhill instead of uphill. So if you have y equals negative x, your line is going to go the other way. So that is your linear parent function and how it can go up by adding a number at the end. It can go down by subtracting a number at the end. And then if there is a negative sign in front of x, it'll flip and go downhill. The next function we're going to look at is a horizontal line. So the name for the parent function is horizontal. The general equation is y equals a, so y can be any number. So y equals some kind of number. If your number is positive, then that horizontal line is going to go up that many, and if it's negative, it's going to go down that many. So your general line would be a line that goes across, kind of like the horizon at the ocean. It's a straight line going across, so that is a horizontal line. If you had an equation y equals 3, you would be going up 3. So your line is 3 units higher than the original. If we had y equals negative 4, you would go down 4 from the original. So that would be your horizontal parent function and how it can go up and down. The next parent function we'll look at is also a line, and it is a vertical line. So the name for this parent function is vertical. And the general formula would be x equals any kind of number. So x equals any number. If that number is positive, then it's going to move to the right. If that number is negative, it's going to move to the left. So your general graph for this would be a vertical line in the middle. So if we had x equals 5, then that's going to shift that line 5 to the right. If we had x equals negative 2, then it's going to shift that line 2 to the left. Notice that these vertical lines are going through the number that is equal to on the x-axis. So your x-axis, this line goes through 5. On the x-axis, this one goes through negative 2. So you get x equals 5 going through 5, x equals negative 2 going through negative 2. The next parent function we're going to talk about is the quadratic function. So we talked a lot about these recently with graphing quadratics and solving them, quadratic formula, and factoring. So the general shape for a quadratic is a U shape. You're always going to have x squared or squared on the outside of your parentheses. That's going to make it a quadratic, and that's where we get the U shape. So quadratic is always going to be a U shape. So your general equation is y equals x squared, and it's going to look like that. Now we take a look at this equation. This tells us how we can move. So the number on the outside, the k value, moves you up and down, and it makes sense. So if it's a positive number, then it's going to move you up. If it's a minus sign or a negative number, it's going to move you down. The number on the inside is going to move you left and right, but it's opposite of what you think. So if it's a minus, you're going to move to the right. If it's a plus, you're going to move to the left. And then the value in the front, that a, if it's a negative, then it's going to flip the graph upside down. So generally, with this equation, this is going to tell you up and down. And it makes sense. Up is positive and down is negative. This is going to tell you left and right. And it's opposite. If it's positive, you're going to the left. If it's negative, you're going to the right. And this, if it's negative, the graph flips upside down. So let's look at an example. Y equals x plus 2 squared plus 3. So this plus 3 on the outside is going to tell us to go up 3. The plus 2 on the inside is going to tell us to go left 2. So we're still going to have a U shape, but we're going to go up 3 and then left 2. So that's going to be the vertex of our quadratic. So we're going to make our U shape, and it would look like that. Let's look at another one. So let's do y equals x minus 1 squared. So in this example, we have y equals x minus 1 squared. There's nothing out here. That means we're not going up and down at all. This minus 1 on the inside is going to move us to the right 1. So we move our graph to the right 1. We're not going up and down at all. So this is our vertex. And then that's going to be your U shape. The next function we're going to talk about is the cubic function. So cubic function is always going to have x cubed, x to the third, or you'll see the cubed or the 3 exponent on the outside of the parentheses. So the general shape for this is kind of hard to do sometimes, but it's like this little swivel that goes through the origin of the graph. So that would be y equals x cubed, that red graph that I just drew. So in this general equation, it works the same way as what we just talked about. So k on the outside is going to go up and down. And it makes sense. Up is positive, down is negative. The inside value is going to be left and right, where it's the opposite. Left is positive and right is negative. And then the value in the front, if it's a negative, will flip your graph upside down. So let's look at an example. If we have this equation, y equals x minus 2 to the third, and then plus 1. The plus 1 is going to tell us to go up, and then the minus 2 is going to tell you to go to the right. So from the origin, we're going to go up 1, and then to the right 2. So that's going to put a point here. And then that's where we'll make our swivel. Like that. So instead of going through the origin, the swivel happens at that up 1 to the right 2 value. So very similar to the quadratic, the ups and downs and left and rights are the same thing. It's just a different shape. So the next function we're going to talk about is the absolute value function, where you're going to see absolute value bars around x or taking the place of parentheses. The absolute value has a v. The graph is always going to be a v with the point generally at the origin. So we have y equals the absolute value of x. We're going to have a point at the origin, and then it's going to go and make a v. So this general equation that we have here, y equals a, and then absolute value of x minus h plus k. It's the same thing as the other two. The value on the outside is going to be up and down, but it makes sense. So up is positive and down is negative. The value on the inside is going to be left and right, but it's opposite, so left is positive and right is negative. So we make an example of this. Y equals absolute value of x plus 1 and then minus 3. The minus 3 on the outside is going to tell us to go down, and then the plus 1 on the inside is going to have us going left. So from the origin, we're going to go down 3 to the left 1, and then make your v. So that would be that function. Once again, similar to the ones that we did before, with the up and down and left and right, it is just a different shape. So this shape would be a v. The next function we're going to look at is the exponential function. So with the exponential function, you're always going to have an exponent of x. So exponential exponent of x. The general, a lot of time you'll see some kind of number, whatever that number might be, and then with the exponent of x. So this graph is always going to go through 1 unless we move it up or down with a shift, and it's just going to swoop up. So that should general form, so that will be y equals 2 to the x. The graph would look like that. The k value plus k would move you up and down, and then if you have parentheses around the exponent, that h value is going to move you left and right. We're not going to worry about that part. We're just going to talk about shifts going up and down. So if we had y equals 2 to the x and then plus 1, that would be a shift going up 1. So from the original point, we're going to go up 1. So it's going to put us 2. That's where it can kind of get confusing because we're not starting at 1. Even though we see plus 1, we're starting up 1 from the original, so that would be 2. And then we do that swoop. Another example, we had y equals 2 to the x minus 3. We're going down 3 from the original. So originally it was at 1, so we're going down 1, 2, 3. So our point's going to go through -2 and then swoop. So that is your exponential function. Our next function is the square root function. So just like it sounds, if you see a square root in your equation, then we have the square root function. Our general function would be y equals the square root of x, and it's going to look like this. It's going to start at the origin, and then it's going to swoop like that. So we take that general equation, y equals a, and then the square root of x minus h, and then plus k on the outside. Same thing as before. The value on the outside is going to be up and down, and it makes sense. Up is positive, down is negative. Value on the inside is left and right. But it's the opposite, so left is positive and right is negative. The value on the front, if it's negative, is going to flip your graph upside down. So let's look at an example. So y equals the square root of x plus 2, and then minus 3. The minus 3 is going to move it down. And then the plus 2 is going to move to the right. So starting at the origin, that's where that point was, we're going to go down 3, and then to the, I'm sorry, this is not going to move you to the right too. It's the opposite. We're going to go to the left. So starting at the origin, we are going down 3, and then to the left 2. And then making that swoop shape. So similar to all the other ones, with the value on the outside being up and down, and then the value on the inside being left and right, but the opposite. So that was our last parent function. So now we're going to look at a couple examples. First one, f of x, which is the same thing as y, equals x squared minus 2. So because it's got x squared, or x to the second, it is a quadratic. So that's the name. And then the transformations, since that minus 2 is not inside parentheses, then that means it's on the outside, and it's going to go down 2. So from the origin, we're going to go down 2. So we're going to have a point at -2, and then we're going to make that U shape. So that would be y equals x squared minus 2. Let's look at the next one. So f of x is equal to the absolute value of x minus 3. So your general form for this looks like that, where this is your up and down, and this is left and right. So we have minus 3 on the inside, so that is going to tell us to go to the right 3. And we have absolute value bars, so this is an absolute value function. So from the origin, I'm going to go to the right 3, and put a point there, and then I'm going to make my V shape. So noticing that my V comes to a harsh point, whereas my U shape is curved. That's important in telling the difference in the absolute value and the quadratic graphs. We're just going to look at 2 more examples. So the next one we have f of x is equal to the square root of x plus 5. So this is a square root function. And the plus 5 on the outside is going to tell us to go up 5. So from the origin, I'm going to go up 5, and I have that point here. And then the square root makes a graph that looks like that. And then number 4, because it has x squared, that means it's a quadratic. And looking at the equation, this is going to tell us to go up 1, and this is going to tell us to go to the left 2. So from the origin, I'm going to go up 1, and then I'm going to go left 2. And then a quadratic is a U shape, so I'm going to make my U shape going through that point. So that's just a quick review of all the different parent functions that we talked about.